now we'll see the next technique, that is estimating cube roots. Now what is estimating cube roots? Okay, I've already explained you what is estimating square roots. Okay, the square area is given some number, you have to find the sides. In the cube also same thing. So this is a cube, right? Just a rough diagram, okay? Yeah. So the area of the cube, now you had been just now in the previous concept, like cubing numbers, you're finding the area of a cube. Now here, they'll give you the area, you have to find the sides. Okay, what number into what number into what? The same three numbers are same. When you multiply with these numbers, you have to get that area. Okay, so that's called estimating cube roots. Okay, so here is also a small table which you have to remember again. So first you learn the table, and it's so easy, this table, it is so natural, we can learn this table in just about 30 seconds. It's so natural, this particular cube table. Okay, now this side write down cube number ending with, and this side write down cube root ends with. Now just like the square numbers, not all the numbers are cube numbers. Okay, the cube numbers are, okay, 0 is a cube number, okay, then 1, then 8, okay, then 27, okay, then 64, then 125, then 216, then 343, then 512, then 729. Only these numbers are perfect cube numbers. The numbers like 2, 3, 4, 5, 6, 7, they are not perfect cube numbers. Numbers like 9 to 26, they are not cube numbers. Okay, so this cube of 0, cube of 1, cube of 2, cube of 3, cube of 4, 5, 6, 7, 8 and 9. Okay, we can just go ahead like this. Okay, only these numbers form perfect cubes, not all the numbers. Okay, so cube number ending with. Now just like the square numbers end with 2 zeros. Similarly, the cube numbers end with 3 zeros. Cube number never ends with 1 0 and 2 zeros, they end with 3 zeros. If the cube number ends in 3 zeros, cube root ends with 1 0. For example, 10 cube. How much is 10 cube? 10 cube is 1000. See, 1000 has 3 zeros, 10 has 1 0. Now 1000 is the cube number, 10 is the cube root. Got it? So we need to know that. Okay. Now, cube number ending with 1, cube root also ends with 1. I'll not talk about 2 and 3 now. Then cube number ending with 4, cube root also ends with 4. Cube number ending with 5, cube root also ends with 5. Cube number ending with 6, cube root also ends with 6. I'll not tell about 7 and 8. Next, cube number ending with 9, cube root also ends with 9. I did not mention about 2, 3, 7, 8. You all remember in the concept of square roots, square numbers do not end with 2, 3, 7, 8. Now see what a funny role they play in cube roots. Okay, if the cube number ends with 2, cube root ends with 8. If the cube number ends with 8, cube root ends with 2. They swap with each other. Okay. Similarly, there's no space here, I'll write here. If the cube number ends with 3, cube root ends with 7. If the cube number ends with 7, cube root ends with 3. Now see what an amazing link, you know. This 2 and 8, when you add together, they add up to 9. See, 2, you know, if the cube number ends with 2, cube root ends with 8. 2 and 8 add to 10. If the cube number ends with 8, cube root ends with 2. Both add to 10. Similarly for 3 and 7, see, if the cube number ends with 3, cube root ends with 7. 3 and 7 add to 10. And cube number ending with 7, cube root ending with 3, both add to 10. Okay. So only for numbers like 2, 3 and 7 and 8, you have to be careful. That's it. If it's 2, it's 8. If it's 8, it is 2. 3 is 7. 7 is 3. For remaining all numbers, it's the same number. 000 is 0, 1 is 1, 4 is 4, 5 is 5, 6 is 6 and 9 is 9. Okay. Now, this is like the table which you have to commit to memory, which is very natural. Okay. And you must also commit to memory the cubes of numbers from Like of course 0 and 1 are very easy. Only from 8 to 9. I mean rather 2 to 9. Okay. 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125, 6 cube is 216, 7 cube is 343, 8 cube is 512 and 9 cube is 725, 10 cube is 1000. That's very easy. Okay. So first you learn this table and this cubes. Okay. After you come in this memory, get back to me. I'll teach you how to estimate the cube roots in just less than 3 seconds. Okay, now let's pause an example. What is the cube root of 3375? See, this is a symbol of cube root. The same square root symbol with 3 before that. Okay, so whatever number is there, it becomes that root. If you keep 4 there, it becomes 4th root. If you put 5 there, it becomes 5th root and so forth. If you keep m there, it becomes nth root. Okay, right. Now, in the square roots, we are underlining two numbers moving from right to left. The same thing for cube roots also, but in cube roots, moving from right to left, group like 3 numbers. Okay, so move like this. Okay, group 3. So there's only one number here, so underline this 3 also separately. Okay, now the right underline, just like the square root rule, is only to check what the cube number is ending with. The cube number is ending with 5. So according to the table which I taught you at the very outset of this concept, if the cube number ends with 5, cube root also ends with 5. I told you, except for 2, 3, 7, 8, the remaining numbers end with those numbers only. Okay, now come to extreme left number. What is the cube root of 3? Okay, now the same table what I wrote here, see. Now the similar way what we have learned for the square roots, we have learned for cube roots. Okay, numbers from 1 to 7, the cube root is 1. Numbers from 8 to 26, see the number is 27 here, right? So minus 1, you get 26. All the numbers from 8 to 26, the cube root is 2. 27 to 63, the cube root is 3. 64 to 124, the cube root will be 4. 125 to 215, the cube root will be 5. 216 to 342, see 343 minus 1, okay, it will be 6. 343 to 511, the cube root will be 7 up to 511, okay, 343 to 511, okay. 512 to 728, the cube root will be 8. 729 to 999, the cube root will be 9 and so forth. Now based on this table, tell me what is the cube root of 3? See, from 1 to 7, the cube root will be 1. So just write 1 there and that's the final answer. You won't get any 2 options here like in our square roots. No guessing, nothing. That's the direct answer. So when you want to find the cube root of 3375, the answer is 15. Okay, now let's postulate one more example. What is the cube root of 17576? Okay, so moving from right to left, group 3 numbers. So group 3, now there are 2 numbers, so group 2 numbers like this. Okay, now the right underline is only to check what the cube number is ending with. Cube number is ending with 6. So if the cube number ends with 6, cube root also ends with 6. Okay, now come to the extreme left number. The number is 17 there. What is the cube root of 17? Check out here. All numbers from 8 to 26, cube root is 2. So that's it. So write 2 here. And that's the final answer. So when you want to find the cube root of 17576, the cube root is 26. Okay, now let's postulate one more example. What is the cube root of 79507? So moving from right to left, group 3 numbers. So group 3, now there are no 3 numbers here, only 2 numbers. So underline 17 also separately. Okay. Now mind you, the right underline is only to check what the cube number ending with. Cube number is ending with 7. Be careful. For only 2, 3, 7, you have to be careful, right? If the cube number ends with 7, cube root ends with 3. Got it? Okay. Now come to the extreme left number. 79. What is the cube root of 79? Check out. 79 cube root is 4c. From 64 to 124, it is 4. So just write 4 here. And that's the answer. You can in fact, with a bit practice, guess the cube root in just less than 3 seconds. If you can commit this table to memory, the cube table to memory, you can perform very rapidly and you can estimate a given cube root in just less than 3 seconds. Okay, now let's take one more example. 658503, and what's the cube root of this? So there are 6 numbers, mind you. So group 3. So underline 3 and 3 separately. Okay? Now, the right underline is only to check what the cube number is ending with. Cube number is ending with 3, the cube root must be ending with 7. You know, if it's 7, it's 3, if it's 3, it's should be 7. Okay? Now come to extreme left number, the left underline. 658, come and tell me according to the table, what is the cube root of 658? All the numbers from 512 to 728, cube root is 8. So write 8 here, and that's the final answer. Okay, the cube root of 858503 is 87. Okay, now let's postulate one last example in estimating cube roots. What is the cube root of 970299? Okay, so moving from right to left, group 3 numbers. Okay, so group 3 and group 3. Okay, now the right underline is only to check what the cube number is ending with. Cube number is ending with 9, so the cube root also must be ending with 9. Now go to the extreme left one. Okay, 970. What is the cube root of 970? Take a look at this. See, 9. See, 729 to 919, all those numbers, the cube root is 9. Okay, so write 9 here. So that's the final answer. The cube root of 970299 is 99. Now, this technique can be applied up to nth root. It can be like, you already know square root and cube root. It can be extended to 4th root, 5th root, 6th root. You can go up to nth root. Okay, the same technique is applied. But initially you only master square root and cube root and gradually increase it to the other roots. Okay, so with this we end the topic of estimating